How does a rock become a chip? First, a piece of quartzite is crushed and broken down into quartz sand. Through high-temperature smelting and chemical purification, such as the hydrogen chloride reduction method, polycrystalline, silicon with a purity of over 99% is obtained. This high-purity silicon is then heated in a quartz crucible until it melts. A seed crystal is inserted, and using the Czochralski process, a cylindrical single-crystal silicon ingot is slowly pulled and grown. The ingot is then sliced into wafers just 0.7 meter thick using a diamond wire saw. After polishing and cleaning, the surface of the silicon wafer becomes smooth at the nanometer level, forming the silicon wafer substrate. To manufacture a CPU chip, the entire process takes around 90 days and requires the coordinated work of hundreds of specialized machines. Given the nanoscale manufacturing process, the precision involved is extremely high. The completed wafers must undergo transistor and defect inspection. During production, defects in some transistors are inevitable, but this does not affect the core functions of the chip. Wafers are graded based on the number of defects. Areas with the fewest defects are used to make high-end i9 processors. Areas with a few minor defects go to i7 and i5 series chips. And areas with relatively more defects are used to produce basic i3 chips. Anyone familiar with CPUs knows they are composed of billions of transistors, with over 100 layers of circuits, stacked on top of each other, each layer precisely connected. If you magnify a chip 100,000 times, you'll see that beneath the dense metal, interconnect layers are transistors made with 5nm technology. Each transistor is just 36.652 nanometers in size, with only 57 nanometers between two transistors. These transistors are covered with insulating layers and metal lines, which interconnect various parts. The CPU chip is built up layer by layer in this way. To complete such a complex and delicate task, we must talk about the photolithography machine. You can think of it as a sculptor in the microscopic world. It has a UV light source and lens at the bottom, and a photomask, reticle, containing circuit patterns at the top, similar to a photographic negative. Inside the photolithography machine, a stage firmly holds the silicon wafer. During operation, the UV light passes through the lens system and exposes the wafer, projecting the pattern from the reticle onto the silicon wafer layer by layer. As chip circuit sizes shrink, ensuring that the printed patterns are sharp is the biggest challenge. To solve this, advanced algorithms continuously monitor and adjust the photolithography precision in real time during exposure. Every optical component works in tandem with its corresponding software.